get water. So okay. 765 couples holding hands. N couples sit in two end seats arranged in a row and want to hold hands. We want to know the minimum number of swaps so that every couple is sitting side by side. A swap consists of choosing any two people. Then they stand up and switch seats. The people and seats are represented by an integer from 0 to 2 and minus 1. The couples are numbered in order. The first couple brings 0, 1. The second couple brings 2, 3, so forth. The couple's initial seating is given by row sub I being the right of the person who is initially sitting in the I seat. Okay, and we just want to essentially, okay. So this feels like a sorting problem, maybe not, or maybe dynamic programming. Sorry, it's dynamic programming. um, excuse me. I'm just looking through, kind of see if I missed anything obvious. So call is that n is 60, or I guess n is 30 for 30 couples. And okay. So what I'm thinking right now is let's say we only look at the first two seats, right? Which is in this case maybe 02. Does it ever, like, is there a scenario in which we want to swap out both of them? Or does it always make sense to use one of them in that? Does that kind of make sense? Hmm. Uh, yeah. I think you always want one person because does that even generalize? What's because, okay, so let's say, well, the maximum answer has to be at most n, I want to say. Uh, yeah. Also, hi, my Ange. Thanks for the comment. Because I think the answers are most n, right? In this, I think that is maybe, well, n plus one or something, maybe off by one, but or n minus one maybe even, because this the swap, because because the swap always makes you one closer to the answer, and so if you have 30 couples, then you have at most 29 swaps. Right? So okay, is there an induction-y thing from that? Uh, I think the other thing I'm thinking about is really high-powered math. Well, it's not really high-powered math, but it's higher than you would expect on an interview, which is counting the what they call permutation cycles, which is kind of um, okay. So I think you can actually solve this with a depth first search because of that. It's kind of or union find or something like that because you could calculate. Sorry, I know I'm not explaining it. I'm just trying to think it through a little bit, but if you see what they I forget the actual mathematical term, But if you similar to kind of what YH example is, you have three couples and they, you know, if you have three couples, first of all, there's never going to be a case where you only need, wait, am I saying that right? There'll never be only one couple out of place, right? Because there always have to be two couple out of place, and then there is one swap. Um, so then I know I'm not gonna. I think I know the answer, which is what I said, but I don't know if I could convince someone of it easily. Uh, if that makes sense. Uh, but basically, given how do I describe what I'm thinking? But basically, let's say you have you start with everyone in the same or like in the ideal coupling place, um, and then what? And then you either have two out of place, and then that creates like a swap cycle. And then when you swap another two couples, you either swap something that's unrelated to your previous swap, or it is related to one of the previous swaps, and then you could kind of uh, yeah, and then you could kind of add it to that cycle. But now my question is, what happens if you kind of connect two different ones? Does that work together? Huh. Let me just work out some uh, examples in my head. Oh, not in my head, but sketch it out. Okay. So what happens if you have, let's say you tied one with couple one with couple two, so that you swap those or one of those in those group, and swap 3 and 4. So now, let's say an example of this would be, and I'm just going to use better numbers. Let's say one, like not the ones in thing, it's just a couple number. So now let's say you have 1, 2, and 2, 1. I guess just 2, 1, 2 is fine. 3, 4, 3, 4. Then you swap 1, 2, 1, 3, 2, 4, 3, 4. Then how many? What's the minimum swaps here? If we do our cycle-y thing, I mean, then technically they're all connected, and since the component size is 4, then you need 3 cycles to 3 swaps to correct them. But can you correct them in a way that is in direct? Okay, well let's just do the greedy quote unquote way. So now we do 1, 3, 2, 4, and then 3, 4. So now 2, 2, and then the 3 goes to 4. Okay, so maybe that still holds what I said. I feel like I don't know if I could accurately, I don't know if I could describe this problem solution in an easy to understand way. But the way I mean, I kind of tried a little bit, but hopefully that's all right. Well, before I try more, let me see if that actually solves the problem, because that'll be embarrassing if I'm like, I'm going to explain this whole spiel in the next 20 minutes, and it's like, whoops, actually, no, this is not right. But okay. Um, okay, and I'm gonna lie a little bit, and readjust everything. So we just want the couple number. I don't feel like we need to know which particular person it is. That's what I'm doing here. And then now we want to do, I mean, yeah, if it's just components, then we could do, whatchamacallit, either union find or depth first search. I'm going to do depth first search though. Um, Okay. Do this at a good price. Okay. Union find is so much easier to understand. Maybe not. Maybe I lie. Okay. I mean, I'm just gonna do the lazy union find and then we'll see. I'm also implementing this from my memory. I haven't done union find in a long time actually. So yeah. Actually, no, we don't. Yeah, we don't need anything here. I don't know how did step is equal to 2? Isn't that right? It's been a while since I needed to step by 2. Something like that, too, right? Am I making this up? I think of another language. Okay, so maybe. Okay. So no, what am I doing? So now we want to. Yeah, okay. Maybe I should just write a class for this. Yeah. Alright. What is n again? 60? Okay. I wanted to write the path compression union pair, but for the sake of me being lazy, I'm just gonna do the lazy one. No, that's not right. Man, I don't remember union fine, but that's good. I think it'll force me to practice it, so probably for the best. Just make sure it should be determined. Let's take a little bit. What happens with the cycles? Yeah, that's funny. Sorry, I'm just thinking. It's been a while. Then the 2's parent is 1. Forgot what happens in the cycle. Should be okay though. Okay. Yeah, I'm just going to do n squared because I'm really rusty. But there's definitely there are ways to kind of pre-cache all this, but maybe I need to kind of go over it later, or maybe just rewrite it in depth search. Yeah, right. Oh man. That's right. I guess that doesn't matter per se, but whether it's just 0 then. Oh, actually, then it would maybe. Okay, maybe I just have indentation incorrectly. Almost said it didn't matter, but I guess maybe it did. I also had other examples. A lot of examples we can do, so we'll have to try a bunch of them first. Let's see, try this one. Now I have to convert it into data format though. That's 0, 1, so that's 2. 1 again, so this is 1. That's 3, 3 is 4. 1, 2, 3, 4. Okay, so 4, 3, 5, 6, 5, 7. Okay, this should be 3. Okay. Am I ready? Well, yeah. It's too late for it to get things like, oh man, that's rough. Okay. I think I should have tested a little bit more if it wasn't 1 a.m. But okay. So one. Sense maybe. Well, let's just put in the row. Maybe there's some weird thing that I was lazy on. Missed about union fine. Like half compression or something. Okay, so this should at least give us 2. I don't know, that's the parent. Yeah, okay, that's what happens when you don't path compress, I guess. Because your parent is not your parents' parents. Okay. Thought I forgot something about. Fine. I gotta review it. So I usually do it with path compression normally, but okay, here we take the lower index. Or bigger, it doesn't really matter. As long as we're consistent. Maybe I should have written my own class. This is good enough. Anyway, I forgot some. I'm too tired. It's 1 a.m. Silver box. Okay, well. Okay, I should try a little harder though. Okay. Probably still something similar. Two prime is 2, which is fine. 3 prime is 3. Yep, I'm just wow. So 1, 2, 3. Well, the 2, 2 is fine, but yeah, the 2 is fine. And so 3, 1, 3, 1, 4, 4. So they should all merge together. But yeah, again, it's because I'm lazy and didn't do path compression or whatever. I need to write a helper class. Fine. I should have bit the bullet. I think I started doing things way too confusingly. I think the union part's actually fine, but the find part I didn't get the parent of parents. I just get the parent, which is clearly wrong. I don't know. I'm gonna blame it on the 1 a.m. part because I think I know what I'm doing, maybe, but I'm not showing it. So, which is also the case on interviews, right? It doesn't matter if you know it. If you don't show it, doesn't If you don't show it, then effectively you don't know it. Because this is just one. So this means if the root is itself, which is fine, but this is if maybe I'll just keep it consistent. All the things I did because I was lazy, well, came back to haunt me. Nice. Oops. Actually, missed a lot of that. This isn't even. Sorry, friends. Maybe I should have started the stream earlier. Oh wait. I forgot that Twitch was down for a little bit. Well, it wasn't down, but you couldn't log in to stream, so yeah. It's cached. Oh, line 9. Oh man, still well. Huh. So it's pairs of 2s. Man, maybe I'm just wrong about this. The parent itself. I mean, merged with what 3, so maybe I've implemented stuff wrong. Alright. Well, this should have been the easy part. Maybe I should have done depth first search. Depth first search I at least know. And that's, yeah. looking at it again. Student index and then first index. How come I don't merge that? Decide if I have an off by one. Yeah, this is right. Okay, oh no, this is right. So merge that. And O3. Did I command my unifying I mean, clearly because I changed it. Okay, I don't know how to do that for search apparently. I mean, union find apparently I have to review it because now it finds. So I don't union correctly. I just changed one of these to another thing. Yeah, okay. So I'm just looking up union find real quick. Yeah. I did this a little weird. Because it's flopping back and forth and everything. But it's something that I should still be better about. Yeah, probably. It's 1:07 p.m. so a.m. even. So I mean, I'm not gonna say I am sleeping afterwards, but I'm probably gonna get some food or something. Yeah. Oh, this is why. It should be. Oh, it's okay. That was just a. Because you have to update not the leaf nodes. You have to update the roots. Okay. Yeah, really rusty. And the worst part is, even if I finish this, I don't know if I can explain it well. But oh yeah, thanks now too. Good night. I mean, I think this is mostly right. Knock on wood. So I'm not really that worried about it. But okay, so yeah, I just had it. But it's a good thing to practice because I forgot that I needed. Well, I used the wrong variable in one place. I should have copied and pasted a little tight. Cool. But that's it. Now going back, I think so. Swap is like a weird thing in that. See if I can find a Wikipedia article that explains it better. Swap maps, something like that. Swap permutation cycles. It's something that comes up in group theory or permutation theory or yeah. Okay. So I mean I think I have something like this that will kind of describe the problem a little bit more. Of course, on Wikipedia, of course, cyclic permutation, which I actually, I mean, I kind of have an intuition for, and I've known just from something that I've been doing for, well, not doing, but I've done many years back. But I don't know if I would, expect anyone to know. So right off the bat, that means that if I'm an interviewer, I would not ask this problem. Well, I'll have to kind of do some research to see if there are another ways to kind of formalize this. Uh, but this is of and space because I only allocate for the union find, and the time is because we only do union finds. Well, this is n squared, which you could actually do better than n squared here. You could for each root just hash and count the number of things that belong in that. So I could even do that now, but I mean, my submission time is fast. Okay, only 62%. Well, okay, but in any case, so you could actually cut this down to of n by, you can imagine just using a hash table and then go through it in a loop and then count it that way. I kind of got lazy and did n squared because I wanted to see, at least I want to see that the algorithm works. So I didn't want to think about it, or it's another extra few lines. So that's actually not a great excuse looking back. But in any case, that is the first thing I would fix. The complexity, it's space complexity, as I mentioned, is O of n because it's union find, and assuming that this is O of n because you use hash table lookup here, then the union, you have O of n times the number of unions, times the cost of the union, which is effectively constant if you do path compression. Oh, yeah. Well, number of finds, but the finds are also constant as well. The unions are constant E. So amortized O of n, because Ackermann's constant or reverse or inverse Ackermann's constant is like 6 or something for the size of the universe. So it's O of n. So O of n time and O of n space is how I'd analyze it. So yeah, I would have to kind of see if there's a less cool way of doing it, if you will, in that like maybe there's something that we can figure out with just more core principle, but the n may be bigger, right? Like maybe there's an n square algorithm that also solved this. I mean, I know I did technically n square right now, but our algorithm is effectively O of n, and we just do a little optimization. But there may be more naive n square or n cube algorithm that maybe solves this. So if that's the case, then maybe it's an okay algorithm problem. But otherwise, as it stands, as the way I solved it, I would say this is way too hard because you need to know way too much math for this. I mean, it's a good amount of math anyway, which I would not expect anyone to know even on a senior level. In terms of cleaning code up, I actually did clean up some of this code to make it easier to read early on and also allow me to do path compression by using recursion. I mean, I could definitely clean up some of this in comments. Remove the print debug statements, but I think overall, I think my code is relatively clean and straightforward. And if we have union find as a abstract data structure, then you could even do this in like 8 lines of code or something like that, maybe 10 or whatever. Though I think in general, in an interview, for whatever reason, people do expect you to be able to implement union find. If not, then do it with depth first search. I think I actually a little bit of a war story is that I think I did try to do union find. I did run into a union find like a connected components problem in which I could have done it with depth first search or union find, as I mentioned. And I've actually done this in an interview, and I forgot to do the path compression part, and then I got grilled on for complexity, and I ended up not getting that job. So something that maybe I should have studied again, studied a little bit more. So this is great practice. That's why I forced myself to do it, to be honest, a little bit on stream, because I think if I were to do it again, I probably would have done a depth first search if all I'm optimizing for is kind of correctness. And but here at least I get to practice union find, which is good because as you saw, I had a couple of mistakes here and there, even though I knew the algorithm relatively quickly, and this ended up taking about 40 minutes. But in terms of describing it, I think I drew some examples in the beginning. I hope that I don't know. I don't think I could describe this adequately given this context, but